Hello friends, let's see one more important question. What is KFold cross validation technique? So what is this cross validation technique? There is a lot of misconception and a confusion associated with this cross validation technique. So let me clear with this model related stuff, how this model is related to cross validation technique. First of all, this is not a model building technique. Not model building technique. So you are not using this cross validation technique for the model building, but this method, cross validation, KFold cross validation, is used for a model evaluation, model checking. Model checking. So let's see how this technique is working and how it is helpful for checking whether particular model is good, particular model is better than some other model, or particular model is performing worse in some scenario and performing good on in some scenario. So let's be clear that this is useful for the model evaluation, model checking, not for model building. So I'll make it as a red and I'll make this part as a green. Okay, so this is for the model evaluation. Now let's see how it is helpful for the model evaluation and model checking technique. Let's say we have 1,000 data point and we need to classify those data point into two different class. So it's a classification problem. Now for the purpose of classification, we have a lot of different machine learning algorithm, like a logistic regression we can use. Let's see, logistic regression we can use decision tree, we can use even SVM, we can use a neural network. I'll just name it as a NN. Okay, so we can use number of technique, but how you can decide that whether particular technique or particular machine learning algorithm is better, or model building via this technique of logistic regression or a decision tree or even SVM or NN, which one is better, how we can evaluate it? That's where this cross validation technique comes into picture. So what happens that we have 1,000 data point in a cross validation total as a training point, 1,000 training point. Let's keep aside the all testing point and we do not bother about the testing point, because the first rule in model building or even any kind of machine learning algorithm building, never use testing data as a training. So we are not going to bother about testing data at all. We are just going to work on a training data, and on that training data only, based on evaluation criteria, we will choose whether logistic regression is better working on this 1,000 data point, or a decision tree, or even SVM, or even a neural network networking. So let's start with the cross validation technique we'll apply on 1,000 data point. So what happens that we will divide this 1,000 data point into 5 different chunk of 200 points. So let's say 200 point here, 200 point here, 200 point here, 200 point here, and 200 point here. 5 different fold. So we are dividing this 1,000 point into 5 different folds. So in this case our k is equal to 5. That's where this k is here. So we are folding this input data point into 5 different fold, and we will iterate this training process 5 times. So first training process we will take This first 4 set of data, I'll make it as one color like green. So total 800 point as a training data, and remaining 200 point in a training data we will use it for the testing purpose. I'll make it as a red. Now in a second iteration we will make this fold as a testing data and remaining as a training. In a third iteration we'll make this one as a training data, in a fourth this one, and in a fifth this one. Remaining all we will use as a training data for our model evaluation purpose. I'll make everything green. Then I will explain you how to proceed ahead. Okay, so we have divided the whole training data into 5 different folds. In a first iteration we have taken first 800 points as a training data, and remaining 200 points we will use for the testing purpose. It is nothing but the validation of your model. In a second iteration you will use this first 600 points and last 200 points as a training data, the middle this 200 point as a testing data you will use. Same way you will go for all those training data 5 different times, and in all different times you are going to use all those data as a training data. Keep aside the 200 data as a one fold training data aside for the testing purpose. Now this task we will do for all those 4 different algorithm. Now let's take logistic regression. Now we'll use the logistic regression to evaluate this model. So how we will go for the logistic regression? What we will do, we will apply training data this 5 times. So in a first time we will get some error like E1. So logistic regression in a first iteration we will apply, and this part we will use for the testing purpose, and we will get some training error and some testing error. Based on that we will decide some E1, then we will get some E2, then E3, then E4, then E5. So for 5 different fold for logistic regression we will get some 5 different error. Every time we will get some different error, and we will make an average of all those error. So we'll take an average of all those things, E1 plus E2 plus E3 plus E4 plus E5 divide by 5, and we'll take an average for this. So for logistic regression we will get some average error based on this cross validation technique. The same process we will apply for the decision tree, and we will get some 5 different errors, because in a first fold you will apply for first 800 sample as a training data and remaining 200 as a testing data, and you apply for the decision tree and you will get E1. In a second iteration this much data you will use as a testing, remaining data you will use as a training data, and you will get E2. Same way you will get 5 different error, and you will take an average for the decision tree. Same you will do for the support vector machine also, and same you will do for the neural network also. Now for 4 different model you will get 4 different average error. Now for those model which has an average error minimum, then you can conclude that decision tree has a minimum error, average error, so decision tree is working better on those training data, and it will hopefully work better on a testing data also. If SVM has a less training error or less average training error out of this E1, E2, E3, E4, E5, you can conclude that it's good to build a model with SVM. So this is the model checking process, and you can evaluate that for those input training data 1000 data point which model to choose. So now we have choose all those model. Let's say we have choose the decision tree model based on the training data. So till now we have just selected that which algorithm technique or which model technique building we are going to use. So till now we haven't built any kind of model, and that is nothing but the cross validation we are doing across all different machine learning algorithm with this k-fold different technique. And after the k-fold different technique, for all of those algorithms we will take the average error and the minimum error out of that, through which algorithm we will get, that algorithm we are going to select as our model building process. Now in case of once you decide about the which algorithm you are going to use on those 1000 training data, you will forcefully apply all those 1000 training data on the decision tree, whichever is the algorithm which gives the minimum error, and that is nothing but your final building. So 1000 data as a training apply on decision tree algorithm. So that is nothing but the final model you will get. So that is nothing but the final model. So that's it for this lecture, friends, and that is all about the k-fold cross validation method before start building about the model. It's a model evaluation, model checking process, not a model building process. And a first very thumb rule we have used for the model checking process, that we have never used this testing data as a training. Based on the training data only, we have splitted this training data into two different area, training data plus validation data, and we have come up with the algorithm which gives the minimum error based on the cross validation technique. So if you haven't understood anything, please write into comment. I will be happy to answer your question. That's it for this lecture, friends. If you haven't subscribed my channel, please do subscribe and support this channel. At last, thank you guys for the watching.